So this is the fourth video in a series of factoring, videos about factoring. And we've been talking about factoring trinomials mostly, and basically by an understanding of how they're created through multiplying binomials together. And this is another method for factoring. It's called the grouping method. And it can be applied to trinomials also, but it also can be applied to fourth degree, polynomials with four terms. It's officially called the grouping method, but I sometimes affectionately refer to it as the oh wow method, because there's kind of an aha moment in the middle of the process. So first of all, you have to understand how the way factoring works. That just like you can factor out a number or a variable, you can factor out a binomial. So as you see in this number one here, there is there's really two terms here in one sense. You could think of this as a term and that as a term. If you think of that quantity, the parentheses, as just one thing. So, and notice that in both terms, they both have a factor of a plus b. Okay, because this first term is 5 times a plus b, and the second term is x times a plus b. So they both have a plus b as a factor, the quantity a plus b. They don't have a as a factor or b as a factor, but they have a plus b as a factor. So I could factor a plus b out. So I'm just treating it like one thing right now. And of course, if I do that, I write what's left when I divide each term by a plus b. So 5 times a plus b divided by a plus b is 5. And x times a plus b divided by a plus b is x. And you see what we get is a factored form of that thing. So here's another example. X plus 4 is a factor of both. So if I factor out x plus 4, I'm left with whatever's left over, and what's left from this little term is x. Of course, there's a minus in between, and what's left from this term is a 3. Okay, and then finally, this is really important. Notice that both of these have a factor of x minus 2. So when I factor out x minus 2 as a quantity, doesn't look like a 2, does it? X minus 2 as a quantity. What's left in this term is just x. And notice what's left in this term, you would kind of say nothing, but remember we're dividing by x minus 2, so that means that 1 is left, because x minus 2 divided by x minus 2 would be 1. Okay, so that's the idea. You need to understand that factoring. Of course, number 4, 5, and 6 and on don't look like that. So what we're going to do is we're going to set that up, and that's kind of like the oh wow step. So in this case, what you do, the reason why it's called the grouping factoring method is that you're going to group two terms together. And it doesn't really matter. So if I pick the first two, and I'm going to group 2y squared plus 4y plus 6x plus 3xy. And notice I'm just putting some arbitrary, it looks like I'm just putting arbitrary parentheses in. It's okay to do that because this is nothing but addition, which means the commutative property of price. So I can add any two together I want to. So I'm choosing to group these first two together and the second two together as I'm suggesting I want to group those first. But then when I look at the two of them, I notice that they have a common factor. So I'm going to factor out. So in this, but I'm just looking at one group, not both at the same time. So if I look at this first group, I notice that 2 and y are both factors of both terms. So if I factor out a 2y from just this parenthesis, notice I'm not touching the second parenthesis. 2y squared divided by 2y would just be y, and 4y divided by 2y is plus 2. Okay, so I pulled out a 2y from just the first two. And same thing here, I'm looking for something common to both terms, and I notice that a 2x is common to both terms. So I'm going to factor out a 2x, and that leaves me with a 3. I'm sorry, not a 2x. That's embarrassing. A 3x. And that would leave me with a 2 here and a y here. And this is where we have the oh wow experiences. So I call it the oh wow method. Because when I factor those two out, I notice that we have a situation like we did in the first three, that there's a term, there's a binomial in both terms that is the same. Now notice here I have y plus 2 and 2 plus y, but that is the same thing because it doesn't matter what order I add things, right? Y plus 2 and 2 plus y is exactly the same thing. There's no difference. So now, it's because it's in this situation, I can do the same thing I did up here. I'm going to factor a 2 plus y out of both terms. Because again, my terms are this whole thing and this whole thing. Those are both terms. There's the yellow term and the blue term. So then when I factor out of that, the one thing that's common to both of them, which is y plus 2. Again, I know it's 2 plus y in there, but that's the same thing. So I just pick one of the ways to write it and write it. And then I write what's left. When I divide the yellow term by y plus 2, I'm left with 2y. And when I divide the blue term by y plus 2, I'm left with a 3x, with a plus in between them. Okay? So you get the idea of this. So in number 5, same idea. I'm looking at this. I'm going to group the first two together. So I'll just put a parenthesis around them. Well, actually, I better rewrite this because it's a little bit tricky because that minus, right? So I'm going to go 28 minus 14q. And then I'm going to go ahead and do, I'm going to do plus negative 2q plus q squared. Oh, that's weird. It freaked out on me. Sorry about that. So notice again how I handled that negative sign in there. Because I want to break these into two groups, I really wanted to leave that negative sign attached to the 2. Now I could have taken it out, but if I let it sit on the outside here, then I'd have to change the sign of my q squared also. So by just putting a plus between the parentheses, I was able to leave that negative attached to the 2 and leave the plus q squared alone. You could do it either way, it doesn't matter, but that's the way I chose to do it. So now I'm going to look at the both terms and try to factor something out of them. So when I look at the first term, it looks like 7 is common to, actually 14 is common to both. So I would take out a 14 and that would leave me with 2 minus q. And then over here, I'm going to factor out a q, and that would leave me with negative 2 plus q. And now here's again this is the oh wow situation, but you might be looking at it going, it doesn't look like an oh wow to me because those don't look the same. But again, you have to be able to see with your algebra eyes that those are almost the same. The difference is that, they're actually the exact opposite of each other. So if you multiply 2 minus q by negative 1, you'll get negative 2 plus q. So these are off by a factor of negative 1. So with that in mind, since I'm trying to factor that out, I could rewrite this as 14 times 2 minus q, and write this as negative q times 2 minus q. So you can see I'm factoring a negative 1 out of there. So I'm dividing this negative 2 by negative 1 and dividing the q by negative 1 and then putting it out front here. So now we have the same exact binomial. So I'm going to go ahead and factor out 2 minus q, and it leaves me with 14 minus q. Okay. All right, cool. Now notice this one up here, it actually wasn't in simplest form. I could have simplified this to 28 minus 16q. Do you see that? Plus q squared. And I could have factored that a different way. So notice some people use this grouping method for all their factoring. So they just break the middle term into two terms and then do the grouping. And I don't think that's the most efficient way to do it, but if that makes sense to you and you would like to explore that or like to come in and talk to me more about it, I could definitely help you with that. But notice we could have done the old way, where we break this into, this has to be Q and Q, right? Because that's the only options. And because this is positive and that's negative, they both have to be negative, right? Notice we get the same thing here. And then we're just trying to break 28 into factors that add up to 16. And clearly 2 and 14 would give me that. So you can see that's a different way. We got to the same factoring. Okay, moving right along here, we're going to again group them. Notice we have that negative in the middle again. So I'm going to do it the other way this time. 2ax minus 2ay. And this time I'm going to go ahead and put the negative out here. And that would mean I would write this as 5bx, but I have to change that to negative 5by. Okay, I'm handling the negative a different way this time than I did last time, just to show the two ways to do it. Now, once I do that, I'm going to go ahead and factor out the common factor in both binomials. So here I got a 2a in both. So I'd write that as 2a times x minus y. And that minus is going to sit there, and I'm going to factor out a 5b from both. So 5b, and that would leave me with an x minus y. Okay, and notice oh wow, look at that. I got an x minus y and x minus y. So I can factor out the x minus y, and that leaves me with a 2a minus 5b. Okay, so I'm going to go ahead and I would recommend that you shut off the video and try a few of these. I'm going to pause the video and do a few of these, and then you can come back in and check yourself so you don't wreck yourself. Okay, so there's I did a handful of them there, 7, 8, 9, 10, 11, 12. So there's 6 in a row that are all done. So I'll give you a chance to look those over and check yourself. Of course, you can pause the video and check on that. Then when you're ready to move on, I'm going to talk you through a couple more of these. So again, the idea is I'm just looking at the first two and then the second two, factoring something out of the first two. So if I look at these first two, looks like x squared's part of both of them. So I'm going to write x squared times x plus 3. And then I'm going to, in this next two, it looks like a 4 goes into both. So that'd be plus 4 times x plus 3. Oh, wow. They both have a factor of x plus 3. X plus 3 times x squared plus 4. And there you go. Now, let's get tricky, a little bit tricky. Notice so far I've been always factoring the first two together. So what if I got fancy and said, I'm going to pair these two together and those two together. So in other words, I'm going to rewrite this as 5x cubed plus 5x and minus 2x squared minus 2. Okay, remember I can do that because really minus 2x squared is the same thing as plus and negative 2x squared. And minus 2 is the same thing as plus negative 2. So I can switch them around. And now I'm going to factor out of these first two. So if I factor out of the first two, I get 5x, and that would leave me with x squared plus 1. And then the next two, I'm going to factor out a negative 2, and that would leave me with an x squared plus 1. And once again, I say, oh, wow, look at that. They both have a factor of x squared plus 1. So I factor that out, and I'm left with a 5x minus 2. So even if you flip them around, or you don't necessarily have to take the first two. Sometimes it's easier to see what to draw out if you pair certain ones. Notice in all the other ones, I did just pick the first two and went with that. So it doesn't take a lot of creativity of looking around. I generally just grab the first two and factor out. So in this case, this would be x squared. That leaves me with 2x plus 5 plus, and in this case, it looks like there's just a 3. And that leaves me with a 2x again plus 5. I get that oh wow experience. and I pull out the 2x plus 5 and x squared plus 3. Now keep in mind, these are all going nice and smooth, and it seems like this is a fantastic method, but all of these problems are hand-picked that work with the grouping method. So you definitely can have a 4-term polynomial that would not be factorable. So you could try the grouping method on it, and it would never work, because if it's not factorable, it's not factorable. Okay, so let's go ahead and try this one here. Actually, I think I'll pause it and do the last 3 so you can just check it. And then I'm going to end this video. Okay, so I'll be right back. Okay, so there's number 16, and I came back. I started up again because I've been waiting for this to happen, and it finally happened. So number 17, notice that after I do the grouping method, so I factored out an x squared from both the first 2 terms and -4 from the next 2 terms, and I saw the x minus 3 appear and went, oh wow, factored it. But then when I go down here, notice that x squared minus 4 is actually factorable. So I can go another step, because x squared minus 4 will factor into x minus 2 and x plus 2. And so if I was wanting to factor this completely, I'd have to take that next step down there. So even in the grouping method, sometimes you always have to check to see if there's any other factoring I can do. Notice we got close up here. We got this x squared plus 3, but that's not factorable because it's not a difference of squares, it's the sum of squares. Well, the 3 isn't a square anyway, but like over here, the x squared plus 4, you might be tempted to think that's factorable, but again, there's because it's not a difference, it doesn't work. Okay. I mean, yeah, because it's not a difference. There's a difference of squares factoring pattern, but not a difference of, or not a sum of squares factoring pattern. Okay, so I'm going to do this last one. Factor out an x squared, and that leaves me with x minus 1. And here, notice I'm just going to factor out a -1 in a sense, and that'll leave me with x minus 1. Okay. And again, we have the oh wow, because there's x minus 1 in both, and so then I go x squared minus 1 times x minus 1, and once again I can factor x squared minus 1, so that'll factor into x minus 1 times x plus 1 times x minus 1, and I notice that I have 2 factors the same, so really it would make sense to write this as x minus 1 squared times x plus 1. All right, so there's the grouping method. Hopefully that is, after doing a bunch of these, beginning to flow with you. And that really concludes my video series on factoring.